अब हम लोग ग्रुप 15 की तरफ बढ़ते हैं। जो ग्रुप 15 के एलिमेंट्स हैं उनका नाम है नाइट्रोजन, फास्फोरस, आर्सेनिक, लेड, बिस्मथ। और इसको याद करने के लिए हमारे पास आसान सी एक ट्रिक है, जैसे कि नाना पापा ऑस्ट्रेलिया में सभी। नाना स्टैंड फॉर एन, फास्फोरस, आर्सेनिक, सा, भी।
इस ट्रिक से आपको बहुत अच्छे से याद रहेगा।
हाँ, तो अब जैसे कि हम देखते हैं कि नाइट्रोजन और फास्फोरस है वो नॉन मेटल्स हैं, और जो आर्सेनिक और लेड है वो मेटलॉइड्स हैं, और बिस्मथ मेटल है।
नीचे जाने से मेटल कैरेक्टर बढ़ता है क्योंकि साइज बढ़ता है।
तो ये ऐसा ग्रुप है जिसमें तीनों एलिमेंट, तीनों टाइप के मेटल्स, नॉन मेटल्स एंड मेटलॉइड्स तीनों ही एग्जिस्ट करते हैं। तो अब हम आगे बढ़ते हैं, इसकी जनरल इलेक्ट्रॉनिक कॉन्फ़िगरेशन जानते हैं। इसकी जनरल इलेक्ट्रॉनिक कॉन्फ़िगरेशन NS2 एंड NP3 है।
ओके,
अब हम आगे बढ़ते हैं। So heating effect of ammonium salts. So this is a very good thing. If anionic part is oxidizing, the nitrogen will be the product, and if weakly oxidizing or non-oxidizing, then NH3 will be the product. So let us begin to understand what is these words tell. Okay, so means if the anionic part, if this is ammonium salt, okay, so if it is strong oxidizing, means this one means strong oxidizing anions are this one. This you have to learn, and it will help you in many reactions to answer. We have not to learn it in NCRTs. Okay.
Dichromate ion, chlorate ion, and iodate ion are strong oxidizing anions.
Okay, and weak oxidizing anions are this one: sulfate, one phosphate, and carbonate, and this biphosphate. Okay. Suppose this is ammonium salt, which is consists of strong oxidizing anion, this one chromate. So this sentence told that if the anionic part is oxidizing, then the nitrogen will be the product. Here you can see. And if it is weakly oxidizing or non-oxidizing, means sulfate like weakly or non-oxidizing anions are there, then nitrogen will not be the product, then NH3 will be the product. So you can see here. This you help in remember not to learn and the reactions, you can easily do it. Okay, now move towards next. This we move towards phosphorus. This one white phosphorus. So its reactions are, so before I structure this one means it has PPP, 60-degree angle is between this PPP, and there are about 12 PPP angles are PPP angle exist. If you count it, then you can find it is 12 ppb angles in P4 white phosphorus, and it is the most important reaction for J point of view. This P4 when react with SOCl2, we got PCl3, SO2 and S2Cl2. And there is one more important reaction like that when P4 react with SO2 Cl2. You can see that there is a difference, SOCl2 and here it is SO2Cl2. When it reacts, this will give pentagonal bipyramidal structure PCl5 and SO2. So these two reactions are very important, and this can be easily asked by the JEE in a paragraph form.
So you should remember them.
Yeah, very important reactions, and it is from NCRT only. Now we will move to the next topic, means oxides of phosphorus, which are P4O6 and P4O10. When P4 means white phosphorus react with the limited presence of oxygen, then we got, and when it is heated, then we got P4O6. And when P4 white phosphorus means react with the excess of oxygen,
we get P4O10.
Yes, we get P4O10. Now we move towards the hydrolysis of the phosphorus oxides. Means we will firstly hydrolyze P4O6, P4O7, P4O8, P4O9 and then P4O10. When P4O6 get hydrolyzed, then we got 4 molecules of H3PO3. And when P4O7, then 3 H3PO3, 1 H3P4. This ratio get decreased when this is increasing, if 3, 4, 3, 2, 1, and then it gets 0 H3PO3 here, and the H3PO4 increases 1, 2, 3, 4. And then now we will discuss the mechanism of forming of P4O6 hydrolysis and P4O10 hydrolysis.
Okay.
Yes. And this is the P4O6. Okay, this is the structure of P4O6. It contains POP linkages.
In this structure, every phosphorus is bonded to other phosphorus via one oxygen atom.
Yeah, this POP linkage is there. And now when hydrolysis took place, then H2O attack on phosphorus, these bonds breaks. So whenever 3 bonds are to be broken from each phosphorus. So here 1 bond, 2 bond, 3 bond are be broken. So 3 POH bonds will be formed. Okay. This one breaks, and 3 POH bond forms. So here are 1 phosphorus, 2 phosphorus, 3 phosphorus, 4 phosphorus. So therefore we got 4H3PO3 from here. And this is given here also. P4O6 and hydrolyzed cuts 4H3PO3 molecules. So that's what we have got here. Now we will see the mechanism of P4O10 hydrolysis. Okay. So when H2O attack on phosphorus, these bonds break. So its mechanism is that here POP bond will break from each phosphorus. So 3 POH bond will form. Means 3 OH. This bond will break. This will break, and 3 OH bond will form, and we will get H3PO4. And we will get 4 H3PO4. One from this, second from this, third from this, and fourth one from this. So totally we get 4 H3PO4 molecules.
Okay.
Now move toward our next group 16, which is also called chalcogens. It consists of oxygen, sulfur, selenium, thallium, and polonium. Okay. Now there is one more trick to learn it. That is called us se tipo. Means us means O, S C, and C, T, and po. Okay. This S is for this, and this one for this, and this one for this, this one for this, and this one for this. Now its general electronic configuration is NS2NNP4.
Okay.
Now we see its important oxy acids of sulfur.
So can you explain what are oxoacids?
The acids which consist of oxygen, these are called oxy acids, and if it consists sulfur also, then it's called oxy acids of sulfur. Okay. Now the first important acid is sulfurous acid, which is H2SO3. And I've already mentioned the pyrosulfuric acid. Here also pyro suffix is used. So 2 molecules of H2SO4.
Removal of one H2O takes place from them, and we get pyrosulfuric acid, which is H2SO5.
H2S2O5. Okay. And now we'll move toward the next important acid, which is called caro acid, and its formula is H2SO5. Here is the structure. It is very important structure.
Okay, it contains one peroxy bond.
Yeah, it consists one peroxy linkage. This one is called peroxy linkage. Now we'll move towards next important, that is oleum, which is very important in physical chemistry also. And it's
so here, do we need to remember this alternate names also?
Yeah, it may be asked in the word problems in JEE when they give the salt analysis word problems or P block word problems. They will just tell that when caro acid react with this and oleum react with this, we will get these products. So they will not give this formula.
We should remember that.
Yeah. It is important. That's why I have mentioned here. So oleum H2S2O7 and its structures, both the structures are very, very important for JEE point of views. And H2S2O7 has this structure, one SOS linkage, and it is quite symmetrical. Now we will see the oxides. Okay. Now firstly we will see the acidic oxides. The acidic oxides are which combine with the water to give acid. That's why they are called acidic oxide.
For example, SO2 combines with water to give H2SO3, and CO2 gives carbonic acid, which is H2CO3.
Yeah, it's right.
And N2O5 give HNO3 and HNO2.
Yeah, it's right. So all the non-metal oxides and some metal oxide in the high oxidation states form, they are called acidic oxide. Example, where we can say the metals which are in the high oxidation state means Mn plus 2 Mn2O7 where it is having Mn, having plus 7 oxidation state, and here chromium is having plus 6 oxidation state, and beryllium having plus 5 oxidation state.
So you mean to say that oxides in which the oxidation state of the metal is high, they will form acidic oxides?
Yeah, that's what.
Okay.
And all the non-metal oxide also form the acidic oxides.
Okay.
Means here it is sulfur is non-metal, carbon is also, and nitrogen is also.
So their oxides will be acidic.
Yeah.
Okay.
Now move towards the next, which is the basic oxides. Basic oxides are which give bases with the water. Okay. Examples are Na2O, CaO, and beryllium oxide. Means all the metal oxides are
Basic.
bases.
Okay.
Okay. Now move towards amphoteric oxides. Means oxide which can act as both acid and a base according to the situation.
Okay.
So these are the one which can act as both. Means beryllium, lead, calcium, tin, zinc, aluminium. And it is there is a trick to remember this. इसको आप आसानी से याद कर सकते हैं इस ट्रिक से भी, जैसे कि इस बैरागी प्रभु का संसारिक जंजाल. Okay, B stands for B, beryllium bairagi, this one, this one, this one, this one, and finally this one. It is very important in chemical reactions, and it is important and easy way to learn it. Okay, now move towards neutral oxides. The oxides which are neither acidic and nor
Basic.
Okay.
In other words, they don't react with water
Yeah.
to form acid or either a base.
Okay. These are the neutral oxides, CO, NO, and N2O. These are some of the neutral oxides. Now move towards the very important compound, ozone. It is very important for JEE pointer syllabus. It is every year the JEE asks from ozone in organic and inorganic. Every year they ask, and its property is very important. So ozone has diamagnetic behavior. You have to learn it. And when it is gas, it is having pale blue color, and when it is liquid, it is having dark blue color, and when it is solid, it's have
Violet and black color.
yeah. And these are the resonating structures of ozone. Okay. Now we will see the important compounds for JEE Advanced. Okay, so first one is H2O2. Oh, let's say color change. H2O2 has open book like structure. So you can see here open book. This one is open book structure.
And it also contains a peroxy bond.
Yeah, this one is a peroxy bond as he is mentioning. And this one is a non-planar compound, as it is an open book, so it will not be contained in a one plane. Okay, and it's a polar compound as you see.
Since the both dipole moments of OH bond add up to form a net non-zero dipole moment.
Yeah, you can see that these are as oxygen is more electronegative, so its dipole moment will be toward oxygen, and it is not in the same line, so not cancelling each other, so therefore it is a polar compound. And the H2O2 has the structure, same O2F2 also has the structure, as you can see. O2F2 both are having the same structure, which is open book like structure, and here the dipole moment are in a different directions.
Because unlike H2O2, it contains fluorine atom instead of hydrogen atom, which is more electronegative than oxygen atom, so the net dipole moment is towards fluorine atom.
Yeah, and the structure is same, and the peroxy linkage is also
There.
Okay. Now we move towards the group 17, which are most famous and known as halogens.
Halo means salt and gen means producer,
Yeah,
because most of the salts are formed from halogen.
therefore they are called salt producers. Now we see the electronic configurations. So its electronic configuration will be NS2 and NP5. So Here it is fluorine, chlorine, bromine, iodine and astatine.
So Sohail, can you tell me some trick to remember this thing?
Yeah, I can tell. Okay, now let's see. We can learn it. फिर कल बाहर आएगी आत्मा. So it gives a horror look. Okay.
Okay.
But it's a good trick to remember it. Okay. Now we will see the bond dissociation energy. It is very important for JEE mains and advanced point of view.
Okay.
Okay, because there is an exception. There is not always a proper trend. Okay, fluorine, chlorine, bromine, iodine. Here is a change. Chlorine is first, and bromine, then fluorine, then iodine. And fluorine is behind because it is having the bond pair, this lone pair repulsion. But chlorine is not having. You will ask,
Why? Why Sohail this is happening?
because the chlorine is having a big size. Okay, so the electrons which are there
Okay.
are far apart.
So the repulsions are minimized.
Yeah, that's
due,
what.
due to the
reason.
larger size.
Yeah. And this is the colors of this gases. Okay, chlorine is having the yellow color, bromine red, fluorine yellow, and violet is for iodine.
Sohail, do we need to remember this thing?
Yeah, it is. It can be asked in the word problems. That it is by reacting to some compounds we get the yellow color gas. So this gas again react with something. So we have to remember some gases compounds and some gases colors. Okay.
Okay.
These are some important reactions to memorize for the JEE point of view. Okay. These are the hydrolysis of these. Okay. First we hydrolyze fluorine and we get O2, F minus and H plus. And this is a different reaction because of the small size and high electronegativity. But the chlorine and bromine gives almost the same reaction as the chlorine react with H2O gives HCl and HOCl, and bromine gives, when the bromine reacts we will get this again the same thing, HBr plus HOBr,
Which is called the hyperbromous acid.
yeah, hypobromous and hypohalous. These are these acids are called hypohalic and,
For example, hypochloric acid and hypobromic acid.
yes, and these compounds are called hypohalous acid. Okay. Now we will see some important reactions which are important for the JEE point of view. So firstly we will see this reaction where ammonia reacts with the chlorine and we get ammonium chloride and nitrogen. Here NH3 is in excess.
Okay.
As NH3 is in excess, so nitrogen will be, this is the trick. Okay, you can memorize it by this easily. As nitrogen is in NH3 is in excess, so nitrogen will present in both the products.
Okay.
Okay, and here when ammonia reacts with the chlorine and when chlorine is in excess,
So chlorine will be present in both of the products.
yes, chlorine is here also and here.
Remember that it's just a trick.
Okay, now let's move to the next reaction. When NaOH, and these both reactions came in JEE Advanced 2014 the paragraph form.
Okay.
Okay, so when NaOH caustic soda react with the chlorine in a cold and dilute environment, we get NaCl, NaOCl and H2O. And again when NaOH and chlorine react in a hot and concentrated environment, everything will remain same except this product NaClO3, and both these products are same for both the reactions. The only difference is NaOCl and NaClO3 is
Okay.
the differentiating product in both the reactions. Now we move toward the next group, which is group 18, which is also known as noble gas.
Because they don't react easily with other compounds.
Yeah, and that's why they are called noble. They are above every others. Okay, so these are compounds which come under noble gas are helium, neon, argon, krypton, xenon, and
Radon.
Radon. So its electronic configuration is general electronic configuration is ns2 and p6.
And both the s and p orbitals are completely filled.
That's why they are called inert also. So except the helium electronic configuration is 1s2. Here it is given except because it does not contain the p orbital. Now we move to the most important reaction, which is hydrolysis of xenon fluorides, and it is very important for JEE mains, and it also came in every CBSE also. Here we will see these reactions. When xenon fluoride XeF2 solid react with H2, we get XeHF and oxygen. And when XeF4 solid react with H2, we get these four products. And when XeF6 react with H2, we get HF, Xe and O3. We can see that all these products, this one and this one, are the part of these reactions only.
And one more thing you should also note, that the reaction number 3 is a non-redox reaction, whereas the above two reactions are redox reaction, as the oxidation state of Xe is changing from 2 to 0 and from 4 to 0 in respectively in reactions number 1 and 2.
And now you can see that here the xenon oxidation state is +2 and is changed to 0. So it is a redox reaction. Yes. So and here it is xenon is +4 and is changed to 0. Again oxidation state changes. So it is a redox reaction. And here the oxidation state is +6. And after the reaction take place, the product oxidation is also +6. So there is no change in the oxidation state. So it is a non-redox.
Non-redox reaction.
Yeah. So it ends here.